Okay. Originally, the concept drawing had basically blocks stacked up like this. Of course, they're cast in one piece, but it was supposed to look like blocks stacked on top. But it looks so chunky up here, and it was adding weight that I didn't need. There's no way you can transfer any kind of a load path through this corner down here on all these intermediate treads. So just linked this thing up and thinned it down. It could be thinner, but then your rebar isn't, a nice sweep and curve. The rebar would have to be bent to follow the shape a little bit, and that just seemed unnecessary. We had enough trouble with the helical stairs. We're not going complicated anymore. Oh, also noteworthy. Oh, this is the parts for the top and bottom. And there's a lot of white space here because there's no bottom in the bottom and there's no top in the top. So there's less pieces. These are still the 3D parts. Just taken right off the drawing and flipped down flat. Oh, okay, here, that's what I want to do. Now, it's kind of nice to have a repeating set of parts. These pieces in here, those will be cut into strips, and they'll go over these holes for the rebars. This is upside down in this view. This is the rebars that will be under the top of the step, the parts you walk on. Well, we don't want those rebars to slide left or right, so we'll just take some strips out of that white space, and we only have to get two of them out of it. Well, two out of each sheet, so they can be any size we want. Also, that can be the thing that we put our upright cocoa lumber on, so we're not drilling holes in the deformed parts. But that'll cap off these. These are just through drilled, and that'll cap that off so the rebars get trapped in there. We did that on the helical stairs. It worked great. Another thing you get with this is when we make the drawings, we're going to take wallpaper paste and stick it onto the phenolic board. So all your holes to drill, well, they'll be on the part. You can drill them, but I would put them in the drill press before I put it together. But you could drill them in place if you weren't sure that it was they were in the right place. Like this row here was really up on that side with the square corners rather than down here. Then you might want to wait on drilling holes, or not. Anyway, it's a repetitive thing. In this white space, we need some a cap for this piece and for that piece. Oh, note, there are 4 rebars across under the tread. To go out the other side of the form, you need 4 rebars, so they're much closer together over here. You know, it swings around in an arc. When we get to sticking this thing up, you'll notice that the rebars are rather attractive. It looks better than the stairs. Okay, is that all we need? I think that's covered it. The first video I did on this showed like 5 different iterations of stairs coming from the square chunky looking thing stairs to the one we're going to do. And it really didn't teach anything new. These are dimensions off the actual house, showing where these holes are in the floor. This is a piece of like 3/4 inch phenolic or 3/4 inch PVC electrical conduit. We had a hole drilled in the bottom that the concrete was going to be poured against, And then we had pieces up here, like it covered 3 or 4 of them, that located at the top of the plastic. And then this one would overlap. You'd be a hole here that the plastic went through too. So it would be 2, 3, 4, 5 pieces. And we did that on the spider beam as well up here. There's a bunch of holes around under this for different things. I know these terms that we use seem strange, but we tried laying out a rectangular grid of beams over this house, and it was disgusting. Neither one of us liked it. She walked by and gave me that face, the Filipino pout. I says, "What's wrong?" She says, "That's ugly." She says, "I don't want that ugly thing on my house." So I says, "Okay." And you got to remember that there's tie beams top and bottom on these walls. One at grade level and one of them just underneath of the mezzanine floor. So basically, this is one giant I-beam. All of them, everything you see there is a giant I-beam. And to spread out the load path, well, this is a good place, Danny. See, we got a load path straight down to the lower tie beam on that. But if we would have gone around and just put them end to end, we'd have had half the width of this tie beam to set this beam on. And the way it is now, we can run this corner column basically as far out here as we want, and have great transfer on the load. And the same thing on the next one. We just offset it in, and that made a lanai out here, and a storage closet there, and a temporary B&B type of. This it could be a bedroom. These are not supposed to be rooms. It's structure of the house. It holds the roof up. It's sort of a spline shape for earthquake resistance. There's electrical panels built into these upper posts up here. That's this red shape here. And that's tall enough for a 8-breaker sub panel. And down the bottom we have the terminal strip things. You see there's 2 shapes here, the red shape and the blue shape. The red shape is the size of the post from mezzanine level to the roof, and the blue is the shape down below. There's like 26 vertical rebars in that blue thing, number 16. And the blue one, I'm not sure how many it has. There's probably 5 across each end and maybe 3 on the sides here. But they'd be like number 12. The house gets lighter as it goes up. Because you're only holding up what's above it. So once you get everything laid out and where your walls and crap have to go, you start with the roof tin and angle iron that's under that and C-channels and all, or the concrete slab, like in our case, it's a concrete slab. You weigh it. And how many support points have you got? And you divide that weight by the support points, and that tells you how strong that column has to be. And then under that you have tie beams and walls and stuff. You add the weight of the walls and then also the suspended slab for the mezzanine, and you got a weight factor. And then you divide that by the 20 posts down below, and that tells you how much cross section you have to have or whatever. And we have a safety factor of about 5, on everything. This is our forever house. We're only going to build one. We're not looking to sell copies or whatever people do. I don't know. We wanted something unique, or she wants something unique. I wanted a small cottage. And what's the room count now? 29, about 37 rooms. Counting the outbuildings, the solar powerhouse and the dirty kitchen and a few other things. And there's only one more to go. Connects this part of the house to the dirty kitchen as a glass walkway. so you can go back and forth with whatever the weather is. I get hungry when it's storming, raining. I don't care to go outside. Anyway, once you get a building design, and it's more important than ever on. This was a 7-story building. Obviously, the part, his and hers toilet and a giant shower in the middle is 6 feet square, and a jacuzzi. And then the master bedroom. These, it's measured off these blue walls. The red walls are the next level up. Okay, it's like the second floor in most houses. The blue here, this right there, that's the shape of the actual first floor, the living quarters. And this thing in the middle looks like bicycle spokes. We call that the spider beam. And that's what it looks like. I start off drawing parallel beams like we do over here, like a parking garage, and looking up the 3D, looking up inside the rooms at the ceiling with them all running this way and that. It would have had to have a drop ceiling or a flat ceiling put underneath of it. And my wife walked by, and this is her concept for the house, not mine. She brought it to me on a sandwich wrapper like from McDonald's, drawn out with crayon. Or maybe it was a makeup pencil, I'm not sure. But she slapped that down and said, "Why can't you do this?" I was complaining I couldn't get ready-mix concrete. Of course, now we can. And we had this castle-looking thing designed. And it was so big. This was supposed to be a cottage. It still got a little bit big. And it's gone from what you see here to 33 rooms now, 20, counting the solar room. This is the stairwell room that you see in a lot of the older drawings. Have no idea what that is. It's obviously a wall. It's a wall with 2 windows in it. Oh, yeah, this is her office space upstairs. She's got a corner staked out here that's going to be an office. And there's a door here that goes out onto this deck. The only door out of that level onto that roof deck is right here. This is not living space up here. It's offset walls because the ends of this beam are sitting on beams down here that are sitting on poured concrete walls, and doing them offset each beam can go clear across the wall for bearing rather than halfway across the wall. The tie beams are 14 inches wide, 24 inches deep. So you'd only had 7 inches to land them on, and that's not enough for a beam that size. But doing it offset, one here and one over there, then they both get full bearing. And plus the load pass to the ground, there's 2 load pass. And there's a lower tie beam underneath of all this stuff that the wall sits on. So it just cuts the load in half on everything. And that worked out nice. Anyway, this is the staircase that's shown in past videos. It's already built. This is where the new one goes. You come out of that door. How does this work? This works. Actually, this is rotated. The bottom step is up here, and you come around, and this one is not quite parallel to that wall. Sort of like here. So you walk around that and out this door and into this step and around to get up here. Current problem is that this top step is facing the edge of the roof, and it's only like 4 feet away. So we have to deal with steel handrails or something around here that we haven't even thought about how to do. It's going to be a lot harder than it looks. Anyway, this is where that staircase goes. We got 20 rebars coming off the out of the ceiling here to anchor the rebars to go down. Nothing on the floor because I didn't know where to put them. I didn't know we were going to have this kind of staircase when I poured this concrete down here. this house has evolved. You know, it wasn't supposed to have any internal round staircases, but when they were setting the forms for this, the drawing was showing them from this side, which put a doorway from here into the master bedroom, and then in this into the great room. But they were standing on the other side when they looked at the drawing. So they put the forms up. Of course, they're the same length, so they fit. That put the door over here. And the stairs that would have gone over top of this door had 3 treads of the stairs running across that 4-foot wide door. I'm not sure how you would manage that. Maybe a landing, but it would took up a lot of the room. So the round staircase was to cover up the construction flaw, which changed the door. I don't know if you're supposed to have the building permit revised if you make a change or not. But the thing is so odd, I don't think anybody ever figured it out. And then we were so far past it that it was, we didn't want to have to go back and back up. Okay. That's enough going on and on, I suppose. Oh, that the staircase that had these. I keep not zooming the camera or zooming the whatever. This is the parts it takes to make these center backbone. The monorail or mono stringer. I saw a mono stringer on Villa Feliz. Now his is straight, a landing. You walk across the landing, and then another mono stringer up to the floor. He's also got high first fleet ceilings. I just copied his ceiling height. I copy from everybody. It ends up that it's enough different. Anyway, these parts were actually drawn out, and they will fit together. You just line up one place where they touch and twist them and turn them until they meet up with the other pieces. When you get done, you look inside, see if there's any daylight showing. But I did manage to get it to go together after days. And I might put this on printer paper, or I might do a couple more iterations. I think I'm going to try making the stairs wider to include those hanger rods, and they can end under the tread, and that'll leave the bottom of the stairs completely open. You'll be able to walk underneath some of it. And there's a window into a storage closet behind the stairs. Not big enough for anything but a hammock. It's not really a bedroom-sized room. Okay. I've never made a 3-part video. Being I've screwed this one up and got it too long. Everybody. I've been watching a channel that's if you're interested in anything that have to do with concrete house building, 62 to Freedom is the name of his channel, and he started slip forming his walls. The house is on stilts, right on the coast. I mean, I'd say he's probably 200 feet from high tide line. No, it's less than that. Maybe 120 feet high tide. But he's building a all concrete house on stilts, but he's putting a metal roof on it. I think a concrete slab would be cheaper, but his builder says metal's cheaper. I don't like to have the maintenance on the metal, and then the storm resistance and rust. You can't underestimate that salt spray that comes off of an ocean. And when you actually have waves breaking, it just blows in there like fog, it rusts out everything. It eats your air conditioner apart. The last thing remaining is the tubes in the core, the copper tubes, and but everything else is just gone. All the framework and the sheet metal just falls away. And eventually it falls out of the window onto the ground. It's still running to that point a lot of times. Okay. End to this Odyssey of a... This is the longest video I've ever made. What a screw up. Okay. Bye, y'all. I'll see you next week. Bye.